So hello everyone, this is the next meetup organized by Washington Quantum Computing Group and Warsaw Quantum Computing Group. So in fact, this is our first joint event. And today our speaker, our guest is Dr. Rie Miura, who is a quantum application scientist at Boltz.ai. So Dr. Rie will tell us today about applications of quantum computing for agriculture efficiency and sustainability.
All right. Thanks, Paul. Thanks for having me today. I'm Rie Miura at Boltz.ai. Today, I'd love to share our journey with quantum computing, our challenges that we are tackling, and what we are building at Boltz.ai. So first of all, I'd like to thank all of you for being interested in us and joining us today. I hope you enjoy our story with me. Okay. So who are we? So Boltz.ai is an early stage Canadian AgriTech startup company launched in 2020 with head office in Toronto. Our vision is empower every farmer on the planet to generate more value. So current focus is to build a precision agriculture platform to help farmers look at a bunch of different data streams so that they can really make the best decision on their farm, and they can take advantage precision agriculture and quantum computing. So here's a slide of our team. I'm very proud of our team. We are very fortunate to have very strong technical team members. We are led by Kwan. Kwan is a CEO and founder of Boltz.ai. Kwan has a PhD in astrophysics and had decided to move to data science area. Then he was taking a role as an IBM quantum ambassador. Since he grew up in a coffee farm in Vietnam, a passion about bringing innovation to the agriculture field someday was always somewhere in his heart. So after having demonstrated experiences as an IBM quantum ambassador, he has founded this AgriTech company to innovate agriculture industry with power of quantum computing. And Kevin is our head of science. He also has a PhD in astrophysics and had moved into data science space, but he moved into a bit more niche area. Then he became an expert in time series models related to climate change. Mark is our data scientist and quantum scientist. What is more special about him is he's a corn and soy grower. So he can bring us the precious experiences, and he can share farmers' voice as well as his deep insight from point of view as a grower. Now on the business side, business development side, we are formally supported by Talat and Guri, who are MBA interns and who accelerate our business development and move us forward. So lastly, I'm a quantum application scientist exploring how to combine quantum computing with traditional AI to produce meaningful use cases. So I also have a PhD in astrophysics and spent several years as a researcher. And then I started being interested in artificial intelligence, machine learning, dedicated myself to working as a data scientist. Then following my curiosity and intuition, I decided to jump into quantum computing field recently. So collectively, we are very proud of that. Our team has extensive research experience in data science, quantum computing, and agriculture. And we published over 150 research papers in the high impact journals, including 2 in Nature journal. So let's move to the introduction of agricultural world. As a global trend, agriculture industry is under pressure to 3 demands. First, feeding a growing population. In 2050, the world population will increase to 10 billion by 2 billion more than the present day. This means that the world needs to increase the food production without expanding agricultural land, and also need to use water and energy in a smarter way because the Earth's resources are limited. Second, the second is that being profitable. Food production can be incredibly costly and resource intensive. To understand this, you may need to rethink what farmers do actually. Imagine that farmers are growing a single product that they have to start planting in one season during a whole cycle. You need to keep them alive and keep them in great condition all the way until they harvest. A surge of the costs, such as a seed, fertilizer, pesticides, energy, water, everything, is the main factors that reduce farmers' gross profit. What is more, there are lots of risks that are out of control, such as weather disasters, insects, and pests. They easily take away farmers' profits. And third one is becoming more sustainable, ecological. The global demand for sustainable and ecological agriculture has been growing bigger and bigger than ever. In many countries or nations, farm requirements are announced for sustainable agriculture. These regulations set limits on amount of, for example, fertilizer use. Growers are highly recommended to follow these regulations. So what is the problem in agriculture that makes it less sustainable? So as you may know, fertilizer helps crops grow faster and bigger and helps to produce more crops. However, in average, only 50% of fertilizer is used by crops. The rest over 50% ends up in atmosphere, or it can be washed away from the soil and ends up in waterways, which causes various environmental problems, such as the release of harmful greenhouse gases into the atmosphere and the eutrophication of our waterway that eventually destroy marine ecosystems. So look at the map on the right. This map is showing how much nitrogen is overused in which area on the globe. Note that fertilizers are mostly composed of nitrogen, potassium, and phosphorus. So you can interpret this to a map of excess use of fertilizer. This nitrogen is thought to be originated from the agricultural fields. As you see, almost all shaded regions are red, which means that unnecessary fertilizer are spread in almost all regions. So this is telling us that while increasing the food production with the use of abundant fertilizer, we are wasting resources behind them. What is worse, we are accelerating the climate change by exhaling the greenhouse gases. Also, we are unintendedly killing fish in the sea far from the fields. So eventually it turns out that we won't increase the food production. Instead, we will get something that we didn't want to get. That's why we need to pay attention to sustainability, and we need to improve fertilizer management in smarter way. So what is the origin origin of the fertilizer overuse in agriculture field. The origin comes from a fact that fertilizer management is very difficult. In the last decade, the agriculture industry has achieved some improvements in resource management thanks to precision agriculture. Precision agriculture has been getting widely known, which visualize decision factors help farmers make the best decisions. However, we still see nitrogen fertilizer excess because the current system still does not pinpoint the exact place, exact timing, and exact amount for fertilizer use very precisely. Another reason is that fertilizer easily runs off after a rain. For the effective fertilizer management, farmers need to pay attention to other factors such as weather conditions, soil characteristics, terrains, and their interconnections. So if we do not do anything right now, we will waste not only the potentially unnecessary resources and time, but they can negatively affect soil and water quality. And then crop yields fluctuate, so do margins. So here are the challenges that we tackle. As we've seen in previous slides, sustainable and profitable food production is important, but not that straightforward. Farmers want to increase the yield, also want to maintain quality of crops at the same time. To be more profitable, farmers want to use the fertilizers and water more efficiently. As I mentioned previously, definitely less fertilizers are benefitable, not only for sustainability, but also for fertilizer cost. Because the industrial fertilizer is produced under enormous pressure and very high temperature. Sustaining these high temperature and high pressure needs enormous amount of energy. That is one of the reasons that the industrial fertilizer is expensive. So the water is also costly. 80% of water is consumed in agriculture field in the US, and 50% of water is wasted. Improvement of irrigation system will significantly reduce the cost. To be more sustainable, farmers want to keep soil healthy in organic matter. Intensive use of pesticides and mineral fertilizers are associated with massive losses of organic matter, leading to soil exhaustion and less productive. To keep soil healthy, farmers need to pay attention to the soil conditions carefully and respect to the ecosystem in there. So collectively, we are tackling to reduce the environmentally harmful effects of fertilizer, optimizing water use without reducing the food productivity when using them. So our product, Boltz.ai, tackles these complex challenges. Boltz.ai is an evidence-based decision-making support platform that takes advantage of big data with artificial intelligence and quantum computing. Boltz.ai can include a much broader range of data and their intercorrelations in a single prescription. Boltz.ai helps farmers allocate the key resources, including labor, fertilizer, nutrients, water, and so on, so that farmers can utilize the right resources precisely. So we can bring more benefit to customers. We can give our customers real-time recommendations so they can get the latest information. This is a great value for farmers because many factors that they pay attention to, such as weather, plant, soil condition, never be static. Following Boltz.ai's guidance, they can do what is the best on their farm on that day. Another value that we can add is flexibility, so that we can give customized solution that can address each operation's unique challenges. So we can add values on what each of farmer really pay attention to. So how Boltz.ai's solution engage the sustainability? Using a wide range of data stream as input, Boltz.ai optimizes the total yield and provide a real-time prescription of resource management. By following the optimization guidance provided by Boltz.ai, farmers will not only save costs, but the operation will become more environmentally sustainable because they are more effectively using their resources. So precision agriculture is a key for sustainable and profitable agriculture. And soil properties, moistures, and plant, many factors are not always in the same state across the farm. For example, degree of water absorption or fertilizers much depends on place to place. So satellite image offer an effective way to survey small to large scale operations. From satellite images, we get very detailed plant level of soil map, soil crop health index. You can zoom how the plants are healthy at plant level. And analytics can then be used to pinpoint each crops. So here's an image of the application that farmers will get in their tablet. So you will be notified telling that where and when to need your attentions. Boltz.ai will tell them exactly with the right amount and right ratio of fertilizers and right place to put, and also right timing to place. Here I say fertilizer as an example, but this can be any other resources such as water and pesticides. Little bit more about what Boltz.ai is doing. First, it divides farm into small blocks. Each block has different soil properties, yield, historical fertilizer, water demand. Imagine that you are grading farm blocks into small patches, and the redder colors are lack of nutrients, while the whiter colors are enough nutrient in the soil. Our applications are highly tolerant even for wide range of data, which enable handling multiple farms as an input at the same time. Second, each block is assigned with a list of preset prescriptions of water and fertilizer, weather, crop yield, soil moisture, and many things. And then introduce a linking constraint requiring blocks in a row having the same water prescription, while the nutrient prescription varies block by block. So as you can imagine, there are time series data. So we can look at the time variation over the time. Additional constraint to keep the total amount of water and the total amount of nutrients below a certain policy. Then we optimize all these parameters simultaneously and provide a fine-tuned prescription. So in real world, constraints are coming both from local and global level that need to be paid attention. Imagine that when farmers make decisions, they are looking at the machine availabilities, time constraints, budget, labor shift, market demand, agriculture regulations that they have to follow, and climate changes. So Boltz.ai can include many of these constraints in addition to a large number of variables related to land itself that I already mentioned previously. As you may have noticed already, this is a massive problem already. So finding the optimal decision for every single moment is extremely huge and incredibly complex challenge for farmers. So massive problem is one of the primary reasons that we need a quantum computer. In general, algorithm can be classified into polynomial time algorithm or non-polynomial time algorithm. If you say a polynomial time algorithm, then it means that the runtime or number of steps of the calculation linearly or polynomially increases as the number of input increases. On the other hand, a non-polynomial time algorithm means the runtime or number of steps of the calculation exponentially increases as the number of inputs increases. So the optimization problem of agriculture that we have walked through so far is non-polynomial time algorithm. The runtime for the would increase exponentially under a classical computer setup. But quantum computer, which can yield a polynomial speed up relative to its classical one, our optimization problem become polynomial time algorithm. So here is our actual comparison between classical and quantum computer performance. This figure shows the runtime versus number of fine-tuned resolution cells. Essentially, it is the same figure as the previous slide. Blue dots are runtime evolution of the classical optimizer. We can see that the runtime increases exponentially. Red dots are runtime evolution of the quantum optimizer. Here you have only 4 red dots on the lower number of finest resolution cells, because to calculate for the larger end, we need a future quantum computer that have more qubits than the quantum computer that are available today. But we see that the red dots are almost flat and constant, even though the number of finest resolution cells increases. This flatness is expected not to change even though the number of input increases, which is theoretically proven. So to summarize, with Boltz.ai, we combine a bunch of data streams and bring all data to the hybrid quantum optimizer. Boltz.ai helps farmers to make complex decisions easier in a reliable way by precise and real-time recommendation. During collaboration with a farmer and working with their data, we could estimate that we can succeed to reduce fertilizer use by at least 20%. Then consequently, we can add more value for farmers to maintain sustainability. So here is our current status. Currently, we are working with potential clients for proof of concept, such as a potato farm, vineyards, and corn farm, and also with university and corporations in order to develop our technology, and with incubators to develop the business further. We test the entire system on real operational environments of the real world variables and constraints coming from local and global conditions. So here's one example. We ran a pilot project on a vineyard to optimize the crop input using wide range of data and local and global farmer regulations. We train our models to prescribe crop inputs for 20 blocks of their farm. Each block has its own distinct soil properties and grows different types of grapes. We use historical yield data. We combine satellite images at different temporal and spatial resolution to track daily change in the field. Also connecting weather stations. Also, we do have a connection with IoT sensor from the field. We aggregate spatial data with yield, soil sample testing at the block level too. Then we train AI algorithm that will predict water crop input use and disease emergence. Then we develop a quantum optimization algorithm to search for the best combination of prescriptions. So our system was customized according to the farmer's environment and the requirement. Then we provide the best crop input prescription down to smaller units of the growing area. So now comparison with our competitors. There are several competitors which are doing very similar things as we do, and we are paying special attention to. But what lots of other companies do not have yet is a quantum computing piece. We are very proud to be one of pioneers who are bringing quantum innovation to the agricultural field. So this makes differentiate us. So we are able to ingest multiple data sources from multiple farms at the same time, while the others are able to ingest limited data source. We can optimize multiple input parameters in a single prescription, while the other are able to optimize single input parameters in a single prescription. We can customize very precise prescriptions in time and space domain, and the prescriptions are well tailored down to customers' needs, but the other cannot customize for different output. So next is access to the quantum computer. We are very fortunate to have a partnership with these hardware providers. We are a pure quantum hybrid software company for agriculture. So we use third parties for hardware facilities. Thanks to our partnership, we have premium access to the world-class quantum computers. We can get technical support from them when we need to. Also, we are very fortunate to have a lot of mentorship and partnership from a really broad range of groups, from corporation, non-profit, and academia. We have strong supporters from university, hardware providers, and business developers. We are very grateful to all our partners and supporters for making this happen. So to wrap up, so Boltz.ai is a precision agriculture platform provider powered by quantum computing technology. Our product, Boltz.x, is to help farmers to increase profit in a sustainable manner. The last one, this is the most important. So we want to work with you. If you have any feedback or like to collaborate with us, please do not hesitate to contact me. Also, if you know farmers or business partners who could benefit from this technology, please feel free to contact me or any of us. So thank you for attention.
All right, thank you very much, Dr. Rie. That was a great lecture, great talk. All right, let's try to ask some questions. The first question is from George, and there is also a similar question to, or relevant question from Helen. What size in a farm block? I think this is a question regarding one of the first slides. And another question about the farms. Where are the farms of your clients located? In Europe, Asia, America, or Africa?
So size, it depends on the client, of course. We are targeting small or medium-sized farmers first to start with. So I don't have a number right now, but you can imagine a small and medium-sized farmers. And also we are right now targeting the Canadian farms, but of course we are welcome any other region in the globe to collaborate. Yeah, if you know any farmers other than Canada, also welcome.
All right, thank you. Another question is about raising investment. How much seed money have you raised? Pre-seed or seed, convertible debt, price round, or safe?
Can you repeat again?
Yes, how much seed money have you raised? Pre-seed or seed, convertible debt? And another question about funding. Have you received US grants and SBIRs? How does your revenue model work? Do you have any pending or issued utility patents or international patents?
That's I had to confirm with that team. Okay. And if you contact me later, I'm sure I give back to you the answer after confirming with the team.
Okay. Yes, so there will be a question by email. All right, another question from Martin. What's the improvement level expected in the quantum computing solution compared to those farmers already using digital precision agriculture tech tools?
Yeah, we are in the experimental phase, and quantum computing also is a development phase. So we cannot compare directly. The current system is kind of the resolution of the current system is usually per field. Then our system that we are trying to build is, to make precise prescription at the much smaller level, like width of fertilizer applicator. It's like 20 inches, if I remember correctly. So much smaller smaller resolution than the current one. So the current is the conventional method still need to fine tune the accuracy of the system.
Right.
So with quantum computer, we can handle large number of variables at the same time. Also, interconnection between the variables. With that, we expect we can fine tune the prescription at the plant level.
All right. Thank you for this answer. I have one more question that's a bit relevant. So you presented a chart showing the advantage or possible advantage of the quantum algorithm. And I wanted to ask what's the time complexity of this quantum algorithm? Because you said that the time will not be increasing with the increased number of or the increased size of the input. So is the complexity constant or linear? Because I believe that this is polynomial, yes, because you expect that they might be speed up comparing to the exponential time classical algorithm, yes?
Yeah. Yes. This calculation was done in the kind of with the quantum computer that available right now, 5,000 qubit in D-Wave machine.
Okay.
And to calculate the more larger number of finest resolution cells, we need future quantum computers, and we expect that can be done by 2025, within 5 years or so. Good.
Okay. All right, but these are, I understand that these are the runtimes based on the experimental runs, right, on D-Wave's machine. But so since you run it on D-Wave's machine, then I guess that there must be a QUBO formulation of this problem, optimization problem. So this is some kind of combinatorial optimization problem. And is there maybe a theoretical mathematical proof that the time complexity will be eventually better than in case of classical algorithm? For example, are there any publications, any papers on that?
Yeah, it was theoretically proven, and I cannot say that much detail about the paper. But if you add more qubits, then the runtime can be superior. The runtime of the quantum optimizer can superior to the classical one. When you use the large number, when you want to calculate the algorithm with a large number of variables, large number of the degree of freedom.
Okay. So, but are there any scientific papers about this algorithm or this QUBO formulation that some other scientists can run, or this is just an internal solution currently, and it wasn't published?
I don't have an answer right now. I can.
Okay.
I can. Yeah, give back to you after confirm. Yeah.
All right. Yeah. Fair enough. That's fine. There are two more questions from Mustafa. In what quantum platform Boltz.ai can run? So I understand that it is at least this D-Waves quantum annealer, but there's also a question: can it run on IBM's machine?
Right now we using an energy wave only. In the future, we don't know yet. But
Okay.
of course, the gateway machines also are within our focus.
Okay. All right.
Depends on how the things are going in the hardware providers.
Mm-hmm. Okay,
Yeah.
great. Thank you. All right, I don't see more questions now. It looks that we've already asked all the questions that are posted on our chat. All right, so I would like to thank you once again, Dr. Rie, for a great talk.
Thank you very much.
Yes, thanks for this lecture. And if you still have time, I will just present a few more slides just to present our future meetings. So let me share my screen again.
Yeah.
All right, I think you can see it now. So yeah, the next meeting of the Washington Quantum Computing Meetup will be on 10th of April. And in fact, that would be a discussion panel about applications of quantum computing in machine learning. The next meeting will be in April, 24th of April. I know that there are also some meetings already planned for May. I guess it's 21st of May, at least. But I would also like you to invite you to attend the meeting of the Warsaw Quantum Computing Group. That will be also online only, and it will happen on this Monday, on 29th of March. Yet another QML talk, so it will be also a lecture about quantum machine learning, some kind of an introduction to quantum machine learning. So if you are interested, then please visit our website and also register to this event. Yeah, so this event is actually organized by the Warsaw Quantum Computing Group and the Quantum AI Foundation. So maybe just a few words about Quantum AI Foundation. We are a charity organization aiming to support development and collaboration in science and new technologies, especially AI and quantum computing, but also other fields of mathematics and computer science. So if you are interested, then we invite you to join and follow our websites, Facebook, Twitter, LinkedIn profiles, join our community, Slack, or follow also our YouTube channel where we also post the video recordings from our meetings. And another interesting initiative that I would like to recommend you to follow is Keyword. It's also an interesting initiative in which I'm involved. It's a global network of individual groups and communities collaborating on education, implementation of quantum technologies, and research activities. So we also organize workshops, webinars, hackathons, quantum research internships. We also invite you to join and potentially to form QCousin, a local group here in the US, in Washington, for example. So if you're interested, then we also invite you to follow our websites and our profiles. So that's all for today. Thank you all for attending this meetup, this event. It was a pleasure for me to be a host, to be a moderator. Thank you once again, Dr. Rie, for a great lecture. And we hope to see you next time during our next events on Monday and later in April and in May.